Section 1.4, Trigonometric functions and their inverses. Radian measure. The unit circle is in the form of x squared plus y squared equals 1, where the origin is at 0, 0, and the radius is 1. To compute the radian measure, we use the formula theta equals s over r, where s is the arc length. And you can compute the arc length by using s equals r times theta. Pi equals 180 degrees is used to convert from degree to radian or radian to degrees. Trigonometric functions based on the right triangle with the angle theta. The adjacent is the side next to the angle theta. The hypotenuse is the side opposite to the right angle. And the opposite is the side that opposite to the angle theta. The sine function is formed by opposite divided by hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the opposite divided by adjacent. Cosecant is the reciprocal of the sine. Secant is the reciprocal of the cosine. Cotangent is the reciprocal of the tangent function. The spatial triangle 45, 45, 45, where two smaller sides are equal, and the hypotenuse is square root 2. Another spatial triangle, 30, 60, 90 degrees. The side that adjacent to 30 degrees is square root 3, which is the opposite side of 60 degrees. The side that opposite to 30 degrees is 1, which is the adjacent side to 60 degrees. The hypotenuse side is 2. For the relationship of the x, y, and r in the coordinate system, at the point on the circle, it will tell you the order pair x, y on the circle, and the r is the distance from the origin to the point x, y on the circle. With the relationship of x, y, and r, sine theta is y over r, cosine theta is x over r, the tangent theta is y over r, and the other three trigonometric functions are the reciprocal of the first three functions. Trigonometric identities. The reciprocal identity, for example, the tangent theta is sine over cosine, or the cotangent is 1 over tangent, which is cosine over sine. The cosecant is 1 over sine theta. Secant theta is 1 over cosine theta. Another important identities, the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. 1 plus cotangent squared theta equals cosecant squared theta. The tangent squared theta plus 1 is secant squared theta. Double and half angles formula. Sine of double angle is 2 sine theta cosine theta. Cosine of double angle, cosine squared theta minus sine squared theta. And there are other two forms of the cosine 2 theta as well, as 2 cosine squared theta minus 1, or 1 minus 2 times sine squared theta. Cosine squared theta is 1 plus cosine 2 theta divided by 2, and sine squared theta is 1 minus cosine 2 theta divided by 2. Evaluate the 6 trigonometric functions. The first angle theta, which is 120 degrees, let's locate it on the unit circle, 120 degrees. So we look at the order pair, negative 1 over 2 square root 3 over 2, which is the point on the unit circle. In this case, x is negative 1 over 2, y is square root 3 over 2. The sine theta is from y over r. For the unit circle, r equals 1. So the sine theta is exactly the same as the y value, or square root 3 over 2. The cosine is x over r, or negative 1 over 2. The tangent is y over x, or negative square root 3. The cosecant is the reciprocal of sine, or 2 over square root 3. The secant theta is 1 over cosine of theta, or negative 2. The cotangent is 1 over tangent theta, or negative 1 over square root 3. For the theta, in form of negative 3 over 4 pi, this is a negative angle. It goes clockwise from the right x-axis, which is equivalent to the angle theta by pi over 4. So we look at the order pair, x equals negative 1 over square root 2, and y equals negative 1 over square root 2. Again, this is a unit circle, the r equals 1. So the sine, which is the y value, or negative 1 over square root 2. And the cosine theta, negative, or the x value, or negative 1 over square root 2. The tangent theta is 1. The cosecant theta is negative square root 2. The secant is negative square root 2. And the cotangent theta is 1. In this example, find the exact value of each of the remaining trigonometric functions of theta. The theta is located in quadrant 2. And the cosine is negative 7 over 25. By definition, cosine is x over r, and r always positive, because r is the distance from the origin to the point on the circle. In this case, x equals negative 7 and r equals 25. We are going to find y. Y is square root of r squared minus x squared, or square root of 25 squared minus negative 7 squared. That gives us 24. In quadrant 2, the y value is positive, so we keep y as 24. If you locate it as an order pair in the second quadrant, and then form the right triangle with an angle theta. The x is negative 7, the y is 24, and the r is 25. We use the right triangle to form the sine and other functions. For the sine theta, which is y over r, or 24 over 25. The tangent is y over x, or 24 divided by negative 7. The cosecant is the reciprocal of sine theta. So we have 25 over 24. The secant theta is the reciprocal of the cosine, or negative 25 over 7. The cotangent is the reciprocal of the tangent, or negative 7 over 24. Next example, we express the theta in terms of x using the inverse sine, inverse tangent, and inverse secant function. From the right triangle, the opposite is x, the hypotenuse is 11, so we find the adjacent. square root of 11 squared minus x squared, or square root of 121 minus x squared. To find theta in terms of inverse sine, as we know, sine theta is opposite over hypotenuse. Therefore, the angle theta is inverse sine of x over 11. Similar way, the tangent theta is the opposite divided by adjacent. Therefore, the theta is the inverse tangent of x over square root of 121 minus x squared. Next, for the secant theta, is the reciprocal of the cosine theta. It is hypotenuse divided by adjacent. That gives us theta in form of the inverse secant of 11 over square root of 121 minus x squared.